Yeah, thanks, Joe. And I think what Sam's put up there in the chat is great. The passage from Luke that says, "Consider the lilies, how they grow. They neither toil nor spin. Yet I tell you, even Solomon in all his glory was not arrayed like one of these." Yeah,
Yes,
thanks,
indeed.
Sam. That's awesome. And that's the scriptures just telling us how magnificent flowers are, and how beautiful they are, but also how intricate they are.
Yes.
And so thanks, Diane. I thought that was fantastic. Okay, so I just want to talk about the trigger plant. That's not a trigger plant or a trigger flower, but I thought it was a nice picture of a bee, so I'll put it up there. But the trigger plant is Stylidium graminifolium, which is widespread across Australia. In fact, there's, I think, 150 or so trigger plants, mostly in Australia, that occur across the continent and in Tasmania as well. I'll just see if I can get this one going. There we go. So they're Australian perennials. When they're not flowering, they really just look like grass. So they're not a lily technically, but they very much in their leafing system look like lilies. And their pollination system, from where they get their name from, the trigger plant, is operating off a fast-acting trigger, which I want to describe. That's the beautiful flower that you see. They can grow up to knee height or even a little bit bigger than that. So it uses a trigger to hit an insect with the pollen. The pollen gets deposited on the back of the insect, it's not on the legs as such, as in a lot of other flowers. Hits it on its back, and then the insect will fly off to another flower to get hit again with a trigger that is then the female part. So we'll talk about that as we go. So I didn't want to copy some brilliant photos that are out there. And if you want to go and have a look at this, there's a website called Life in a Southern Forest. And it's got some magnificent up-close photos of how these plants work. But I sought permission but didn't get it in time. So this is my magnificent art just to impress you all with. So look out, Steve Cardno. But here's the parts of the flower. You've got obviously the petals, which, as in most flowers, seem to have some role in attracting insects. You've got the throat appendages there. They seem to be guides to guide the insect into the nectar well there in the centre of the flower. But also those throat appendages seem to discourage insects that are not good for the pollination of the flower from getting into the nectar well. The actual flower stem is quite interesting. The column is a combination or a fusing of the male and the female part. So just the very basics of flower structure is the anthers, which produce the pollen. That's the male part. The stigma is the female receptive part. And then usually the pollen, when it lands on the stigma, will send a tube down the floral tube and fertilise the female seeds sort of deep down in the flower. So these two parts are fused together on this particular flower to produce the trigger. And that's what fires. So we'll have a look at this. This is how the insect comes in, and the insect is attracted to the really rich nectar that's in the nectar well. Seems to really love it, and it's so good that the insect seems to visit many flowers on the same stem and then fly off to other stems, and on they go. It's guided in there by those throat appendages. It can sit and land and on the petals there. It's all perfectly designed for them to do that. And when it puts its proboscis into the nectar well, that sets off cells in there. It causes them to have low pressure on that first bend in the trigger, and it fires up and hits the insect on the back there, it's very, very fast. In fact, it's approximately, it takes about 10 milliseconds, which is 1/100th of a second. Now, when you set this off, it can actually reset. So the trigger will reset, and it takes about 10 minutes to do that. So when you see in the little video I've got in a minute where we've set it off, we're not really destroying the opportunity of that plant to pollinate. But I think that's quite incredible that they can reset as well. And the interesting thing is that the slap on the back, which would have to be quite firm for a little insect, does not deter it. So maybe that's suggesting, one, how good the nectar is, but also I suppose it's a fairly firm back on most of those insects with the cuticle that they have. Now, with the pressure of the trigger on the back of the insect, it stays there, and the insect has to back out of where it's been hit, and that means the pollen sort of scraped off the male part and deposited on the back nice and firmly. And the other interesting thing, if an insect just lands on the flower, it doesn't set the trigger off. It actually has to be feeding in the nectar well to set the trigger off. Okay, so to take that to the next level, there's an order in the flowering of the trigger plant. So the lower flowers are the first to develop. Now, it doesn't self-pollinate because you've got the male anthers right next to the female stigma, and that could cause self-pollination within the one flower, or even if the insect went from one flower to the next flower on the same plant, the plant is still basically self-pollinating. Now, the trouble with that is that can cause like a inbreeding depression, and reduce genetic diversity. But God's worked it out that he wants a broad genetic diversity across organisms as much as possible, and so he's worked it out in this amazing design that the flowers don't self-pollinate. One, because the anthers develop the pollen first, and the stigma is covered up. The female part is covered up while the anthers are producing pollen. And then once they're spent, then the stigma starts to develop and can receive pollen from another flower when the insect then repeats it. So the trigger is going off, one, to release the pollen, and then on a later occasion to receive pollen. But the other thing is there's different stages in the flowering. The lower ones are the first to produce the anthers, and then as the other flowers develop up the stem, they become the receptive part. What's happened there? Sorry, I'll go back to that. There we go. Stage 2, so that's the younger flower that's starting to produce pollen, and then that's the youngest one. So the anthers are full of pollen, but the stigma's not receptive. The stigma's receptive at this stage now on the bottom one. But the really interesting thing is, and it's hard to explain why, maybe there's a difference in the nectar and the nectar well, but the bee or the insect lands on the bottom flower first. So in other words, it's bringing pollen from a previous flower, and it lands on the bottom flower with that pollen, and then it moves up the stem, visiting the flowers as it goes up with pollen from the other flower. Won't matter because they're not receptive at this stage. It'll pick that pollen off and then fly off to another flower and visit the bottom flower on that other stem. So that's an incredible thing that the insects know to do, and I don't think you can explain that in any other way except magnificent design. As I was studying this, I came across a quote from one of the people researching it, and they said, oh, sorry, I keep pushing the wrong button. They said this, after going through all the amazing parts of the trigger plant flower and how it works, evolution, a masterclass in design. Now,
Wow.
that's an incredible statement, because design always comes about from a designer that has an intent, a plan, and a purpose, which are all attributes of intelligence. So I don't know how you can say that blind, random chance evolution is a masterclass in design. But as Diane was saying, I guess that's part of this foolishness that starts to creep in. You can study and look and take close-up photos of magnificent design and then call it evolution. Mm-hmm. Incredible. Well, Sam, if we can perhaps show the video now. This is showing you how fast the trigger is. So it'll show you them firing, and then right at the end, try and slow it up to the slowest speed that we could, and it's still quite fast. So let's have a look at this.
Gotcha. Recording. Oh, yeah, I'm filming. Got me. You're kidding me. Got that? Yep. This will be a good one if we get it.
Yeah, he's already triggered, I think.